go ahead and talk about average rate of change between any 2 points. So we've done rate of change before in terms of slope, and that's all that rate of change is. Rate of change is just finding the slope, but when we have a curve, we're going to artificially say, starting from one point and moving to another point, what was the slope if we just decided to make a straight line between those 2 points? Other than that, it's exactly the same as finding slope. So let's go ahead and find our rate of change. Function is x cubed minus 3x from x1 equals -2, so over here, to x2 equals 0 over here, between those 2 points. So all we're going to do is find the slope between those 2 points. M equals, let's talk about our y values. At the start, our y value was -2, and at the end, our y value was 0. Getting those points from here and here. And then we need to divide by what our x values are. They also happen to be -2 minus 0, so we'll get -2 over 2 for a rate of change between those 2 points of 1. If we do the same thing, but instead go from this point to this point here, we'll call this M1 and M2. Let's look at our y values. We go from 0 to -2, and again, we could reverse these as long as we reverse the x values as well. We go from 0 to 1 in our x's, and so we have a slope of 2 over -1 or -2. Slope is -2. We call it rate of change. On average, how much did we change in between those 2 points? So see if you can find the average rate of change on problem 75. Alright, if you're ready to go, here we go. So we want to find the average rate of change from x1 to x2. So if we plug in sorry, got interrupted. If we plug in f of 0 minus f of 3, which are our 2 values for x1 and x2, and divide by 0 minus 3, we'll have our answer. If we plug in 0 up here, -2 times 0 is 0, plus 15 is 15. And if we go ahead and plug in 3 right here, we'll get -6 plus 15, which is 11 over -3, and so we'll get 26 thirds negative. Can't reduce that at all, so -26 over 3 would be our average rate of change for problem 75.